In this set of video notes, we will be looking at part 3 of section 8.3, adding and subtracting rational expressions. Specifically, we're going to work with complex fractions, which includes adding and subtracting and simplifying by multiplication and division. Let's look at the last slide. Looking at complex fractions, some rational expressions are complex fractions. Complex fraction contains one or more fractions in its numerator, its denominator, or both. So examples of fractions, complex fractions are shown below. So in this case, we have a polynomial on top and a rational expression on the bottom because there's a fraction. And here we're adding a rational to the numerator. And here we have actually a rational expression in the top and the bottom. So both numerator and denominator have rational expressions or fractions. So in example A, let's make this a little bigger. It's going to take us a little work. We have two fractions. So we know that if we have x plus 2 divided by x minus 1, that's one fraction, divided by x minus 3 over x plus 5. So this is our division bar. So we have a fraction here divided by a fraction here. So we can rewrite it with the division symbol. And then we also know that if I take x plus 2 over x minus 1 times the reciprocal, I have x plus 5 over x minus 3. Then I can multiply across. So I end up with x plus 2, x plus 5, all over x minus 1 times x minus 3. And if we look at it, no factor in the top or the bottom is the same as the each other, so we can't cancel anything out. So depending on what use we have for this rational expression, we can either see it as x plus 2 times x plus 5 over x minus 1 times x minus 3, or we can actually FOIL it out. So we have x squared, 2x and 5x is 7x plus 10, over, on the bottom we have x squared, negative 3x and negative 1x is negative 4x, and negative 3 times negative 1 is positive 3. So one of those two answers could be the solution depending, or the simplified version, depending on what the directions say or how we're going to use the rational expression. Okay, let's look at B. In B, we have two fractions. We have 3 over x and x plus x over 2. So we're going to write 3 over x plus x over 2. That has to be one fraction in order to simplify. So on this side, I need a common denominator, so times 2 on top and bottom, and this needs the x and the x from the other fraction. So we have 2 times 3 is 6 over 2x plus x times x is x squared over 2x. That becomes our numerator when we combine it together. So it is 6 plus x squared over 2x all over x minus 1 over x. And then we know that we can write that as, I'm going to flip the x squared and the 6 to be more in standard form. That's really divided by x minus 1 over x. And then if we do division, we switch it to multiplication. So x squared plus 6 over 2x times x over x minus 1. And we can cancel out an x from the top and bottom because it's multiplication. And we end up with x squared plus 6 over 2 times x minus 1. So we can either see it like that, or it's possible we can have x squared plus 6 over 2x minus 2. In the last example, we have two fractions. Notice that they are two fractions, so we don't have to add or subtract. We can just take x plus 1 over x squared minus 1 divided by x over x minus 1. That means we flip the second fraction, take the reciprocal. So we have x plus 1 over x squared minus 1 times x minus 1 over x. And then we'll notice that we have x squared minus 1 squared, which is a difference of squares. So we can rewrite the bottom as x plus 1, x minus 1. And then we have times x minus 1 over x. We put these in parentheses. So I notice that x plus 1 cancels with x plus 1. X minus 1 cancels with x minus 1. So the top is now just 1. So I simplify to 1 over x. And that completes notes on section 8.3.